redox reactions. So redox reactions is when there is reduction taking place and oxidation in the same reaction. Okay, so some equations are very difficult. So for example, if we take this equation here, MnO2 plus 4HCl goes to MnCl2, Mn is manganese dichloride, plus 2 waters plus Cl2. Now, from this equation here, it's quite complicated, and it's difficult to see if a redox reaction is taking place. Is reduction taking place? Is oxidation taking place? Right, because classically, oxidation is the gain of oxygen, and reduction is the loss of oxygen. Okay, now, but nowadays that is too simple. Okay, so we've made the definition of oxidation and reduction more complicated, and now we use the thing to help us remember oil rig. Oxidation is the loss of electrons. So we're just refining the definition. Reduction is the gain of electrons. Okay, but still, in a lot of equations, it is difficult to see whether something is being reduced and something is being oxidized. So redox is when it's happening in the same equation. Okay, so we've got something else. We've got something called oxidation numbers, which is related. Oxidation numbers just shows you what is happening to the electrons, and it's related to the number of electrons that's involved in the bonding. Okay, but there are certain rules with oxidation numbers. Okay, so we're going to look at a simple example first. So if we take a simple example like the reaction of magnesium and chlorine to give magnesium chloride. So it's a nice simple reaction. Okay, so oxidation numbers of elements are always 0. Okay, that's rule number 1. Oxidation numbers of elements are always 0. So the oxidation number of oxygen here is of magnesium here is 0. The oxidation number of chlorine is 0 because they're both elements. Now the oxidation number over here, what you need to do is you need to go, well, magnesium is in group 2, and so it gives up 2 electrons when it's bonding. So the oxidation state of magnesium here is +2 because it's in group 2, it gives up 2 electrons. Okay, the oxidation state of Cl is 1- because it gains an electron. So oxidation state of Cl is 1-. Yes, there are 2 Cl minuses, Cls, but each one is 1-. Okay, and then you go, okay, so the magnesium has changed from oxidation number 0 to +2. Okay, chlorine has changed from oxidation number 0 to -1. The oxidation number of chlorine has decreased, has reduced. Okay, so the oxidation number of Cl has reduced, and so that is reduction. When the oxidation number reduces, that is reduction. When the oxidation number increases, the oxidation number of magnesium increases, then that is oxidation. So I can see that this reaction is a redox reaction. I can see that the magnesium has been oxidized and the Cl has been reduced. Okay, and I can also write 2 half equations for this reaction. I'm going to write 2 half equations to show what is happening here. So if you have, so the overall equation, let's go back to the overall equation again. Okay, if we just focus on this is the overall chemical equation. If we just focus on the magnesium has become Mg2+. It has lost 2 electrons, oil rig, it's lost 2 electrons, that is oxidation. It's called a half equation because it's half the equation. And then the Cl2 has formed 2 Cl minus, and the Cl2, each one has gained an electron, and that is called reduction, a gain of electrons. Okay, so you can easily see this through oxidation numbers, right? So let's have another look. Let's have a look at that complicated example I showed you at the start. MnO2, and the oxidation numbers just help us to see where the movement of electrons, it's related to how many electrons is involved in the bonding between the elements. Okay, so this example here, right? So the first rule was that elements are always 0. Okay, that's rule number 1. Elements are 0. Oxidation, this is the oxidation states rules. Oxidation number rules. Okay, the second rule is that oxygen is always -2. Okay, oxygen is always -2. So if oxygen is -2, but there are 2 oxygens, so that totals -4, then Mn must be +4 because the overall charge is 0. So the oxidation numbers have to add up to the overall charge. So oxygen is -2, and there's 2 oxygens, that's -4, and then Mn must be +4. Okay, so Mn is +4. Then we look over here. Again, Cl is 1- because it's group 7 and forms a 1- ion. There's 2 of them, which is there's 2, so that will total -2. So therefore Mn is +2. So Mn has changed oxidation number from +4 to +2. The oxidation number has decreased. Oxidation number has decreased, and that is reduction. So you can say the Mn has been reduced in this equation. All right, let's do the HCl then. Okay, so Cl is -1, so therefore H is +1. Okay, so whereas over here Cl is 0. So you can see that -1, the Cl, -1 to 0 because it is an element. The oxidation number has increased, and that is oxidation. When the oxidation number increases, that is oxidation. So in this reaction, which looked quite complicated, I can see that Mn has been reduced and Cl has been oxidized. And so oxidation numbers help us to do this. Okay, so back to the rules. So oxygen is always -2. Apart from, there is an exception except in hydrogen peroxide. In hydrogen peroxide, the H is always +1. So that's another rule, number 3. H is always +1. So the H is +1. So if H is +1, and there's 2 of them, and it has to add up to 0 because there's no charge, then that means the oxygen has to be -2. So each oxygen has to be -1, because then it will add up to 0. So oxygen is always -2, except in hydrogen peroxide, when it takes the value -1 instead. Okay, so that's an exception. Now H is always +1, but there's an exception there as well. Okay, except when it is with a metal. So like if you take sodium hydride, the metal is +1 because the metal loses an electron. Therefore, the H has to be -1 because it has to add up to 0. So this is the exception for hydrogen. Hydrogen is always +1 except in metal hydrides. And then it becomes -1. Okay. There's another exception for oxygen. Let's go back to oxygen. There's the second exception. Right, if oxygen is bonded with something that's more electronegative, so oxygen is bonded with fluorine, for example, there, then fluorine is the more electronegative, and that is -1, and there's 2 of them. So that means that's -2. That means oxygen has to be +2. So in this case here, oxygen will have the oxidation state +2. So there are 2 exceptions for oxygen. Hydrogen peroxide, and when oxygen is bonded to something more electronegative, is bonded to something more electronegative, which is just fluorine. Okay, right. So the oxidation states have to add up to the charge. Everything we've done so far. So for example, let's take HNO3. Hydrogen is +1. It's always +1 unless it's with a metal hydride. Oxygen is -2, and there's 3 of them. So we've got -6 +1, and it has to add up to 0 because there's no charge. So that means that the oxidation state of nitrogen is +5. So the oxidation state of nitrogen is +5. All right. Let's take something that is not neutral, that is not 0 charge. Okay, so if you take, for example, let's take carbonate, and I want to find the oxidation state of carbon. Okay, so I say oxygen is -2, because oxygen is always -2, unless it's in a hydrogen peroxide or with fluorine. There's 3 of them, so that totals -6. It has to equal the overall charge on the ion is -2. So carbon something -6 equals -2. So if you have +4, 4 minus 6 equals -2. The oxidation state of carbon is +4. So it has to add up to the charge on the ion. Okay. Let's give you another example then. Let's give another example here. So of a redox reaction. So this one here, if you take aluminium and sulfuric acid, and gives you aluminium sulfate. Okay, so a metal and an acid. And you say, well, what kind of reaction is a metal and an acid? Okay, what kind of reaction? So it's not very clear, so using oxidation numbers, let's find out. Aluminium, the oxidation number of aluminium, it's an element. Elements are always 0, rule number 1. Okay, so what's the oxidation state? Oh, we can see another element here. So hydrogen is 0 because it's an element. Okay, so SO4, we can take this as a whole group. SO4, the whole group SO4 is -2. Okay, because we know that sulfate is -2 like that. Okay, so -2, there's 3 of them. So that would be -6. Okay, sulfate is -2. So aluminium here has to be +6 because it has to equal 0. There's no charge. But there are 2 aluminiums, so we're going to need, each one's going to need to be +3. Okay, so aluminium has changed from oxidation number state 0 to +3. The oxidation number has increased, and therefore the aluminium has been oxidized. That's oxidation. Okay, and then again, let's look at the sulfuric acid. It's nothing to do with the number at the front. We're not bothered about the number at the front, the stoichiometry. It's nothing to do with that. Sulfate is -2. SO4 is -2. So therefore it has to add up to 0. Okay, so it has to add up to 0. So therefore hydrogen has to be +2. There are 2 hydrogens, so each one has to be +1. So hydrogen has gone from H has gone from +1 to 0. The oxidation number has reduced. That is reduction. And that's how you can see if something is a redox reaction. Okay, so reactions of metals and acids is a redox reaction. But the final thing you need to be able to do is you need to be able to the formula of ions, right? Now, if you know that if you have 8, then that means, so let's take for example, if I said to you, let's get an example, nitrate. If I said to you, nitrate 3 ion, okay, and it has a charge of -1. Now, when you have Roman numerals like this, that tells you the oxidation state of the nitrogen. The Roman numerals 3 tells you the oxidation state of the nitrogen. And 8 means there's oxygen present. Okay, so I know that nitrogen is there and oxygen is there. And that nitrogen has oxidation state +3. And I know that oxygen has oxidation state -2. And I know that the overall charge is -1. So it has to add up to -1. Okay, so I need to get the appropriate numbers here to add up to -1. So I can see the common multiple of these is 6. So if I have 2 of them and I have 3 of them, that will be +6 -6, which equals -1. Okay, which that is not correct. We want it to equal -1. So we need, so that's not right. Okay, so let's do that again because that is not right. So let's take NO minus. If that is +3 and that's -2, and we have to get it to equal -1, we need 2 of those, because then that will be 3 minus 4 equals -1. So the formula for the nitrate 3 ion is that we need to have 2 of those. So it's NO2 minus. NO2 minus is the formula for the nitrate 3 ion. Let's try another example here. So if I said, let's try another example. So if we said sulfate 1V, like that, okay, ion, and it has a charge of -2, and you've got to come up with the formula, okay? 1V, so in your Roman numerals, we've got 1 is 1, 2 is 2, 3, this is in Roman numerals, then 4 is 1V, 5 is V, right? And the way to remember it is 5 is V and 4 is 1 before 5, and then 6 is 1 after 6, and then you just carry on 6, 7, 8, and then 10 is X, so 9 is 1 before X is 9. Okay, so those are your Roman numerals. So sulfate 5, so sulfur, I know it contains sulfur. 8, I know it contains oxygen. I know it has an overall charge of -2. I know the oxidation state of the sulfur is 4, +4. I know that the oxidation state of the oxygen is -2, and I know that it has to equal -2. Right, so how can I get this formula so that it equals -2? Okay, so if I have there, so if I have 4 minus 6, 4 minus 6 equals -2, there must be 3 oxygens, and that is the formula. SO3 2- is the formula of sulfate 5 ion. Okay, now the reason why we use Roman numerals, so for example, if I said to you iron sulfate, write the formula of iron sulfate, you could write different things, because iron can be iron 2+ iron, or it can be iron 3+. Sulfate is always 2-. Okay, but which iron are you talking about? Are you talking about iron 2+, or are you talking about iron 3+? So we need to make it clear. Okay, first I'm talking about iron 2 sulfate. So it's the oxidation number. This tells you the oxidation number of the whatever it comes after. So I know that's Fe2+, and so sulfate 2-, I put them together, the formula is FeSO4. Whereas if I said iron 3 sulfate, that's the oxidation number of the metal, iron 3+, sulfate is 2-, right? I know I'm going to need 3 of them, that's 6-, 6+, the formula is Fe, there's 2 of them, sulfate, and there's 3 of them, like that. Okay, so we use Roman numerals to indicate the oxidation number of the atom. There. Okay, let's just do one last example and we're finished. One last example and we're finished. All right, so let's take sulfate V1, which means 6. 1 after 5 is 6. Sulfate ion. There's a charge. The charge on the ion is 2-. Okay, so sulfur 8 is oxygen. We know the charge is 2-. We know the oxidation state of sulfur is +6. We know the oxidation state of oxygen is -2. It has to add up to -2 overall. Right, so if that's +6, we need this to be -8. We need there to be 4 of them. 6 minus 8, we need it to be SO4 2-, and that's the charge. That's the formula of sulfate 6 ion.